Hello, my name is Boris Navarro. I'm presenting my term project paper, Interoperability Challenges in Smart Home IoT Protocols. This is part of the class CNT 4165 Network Protocols for Internet of Things. The smart home market is expanding proportionally with the number of IoT devices connected to the internet, projected to reach approximately 175 billion by 2025, next year. Along with this rapid expansion is the need for seamless integration between devices from different vendors and manufacturers. It is no secret that this divorce has led to frustration and decreased satisfaction, user satisfaction, right? By investigating interoperability, solutions that enable plug-and-play experience can be created and increased user satisfaction, since that is expected by users. The study focuses on integration challenges, understood as the ability for devices from different manufacturers to integrate into a single home ecosystem using protocols such as Zigbee, Z-Wave, Wi-Fi, Matter, Thread, and Bluetooth Low Energy, or BLE. From our personal experience, and after reviewing multiple literature resources on smart homes, I found that it is challenging to turn our homes into a smart one. Literature review yielded some interesting results as the challenges of having so many different IoT protocols used today, and left me wondering about what is being or can be done towards smart home IoT interoperability. With that, 6 IoT major protocols have been dominating smart home integration these days, each with their own features and characteristics that make them suitable for certain cases over others. Zigbee, for example, is a low-power, short-range wireless communication protocol based on IEEE 802.15.4 standard. It operates in the 2.4 gigahertz, 1915 megahertz, and 868 megahertz frequency bands, and is designed for personal area networks with small low power digital radios. It is also widely used in smart home applications due to its mesh networking capabilities, which allow devices to communicate with each other, extend the network range. However, its limited range and potential interference with Wi-Fi networks can pose integration challenges in larger smart homes setups. The second protocol that has been used is Z-Wave. Z-Wave is a wireless communication protocol specifically designed for home integration automation. It operates in the sub 1 gigahertz frequency band, which provides better wall penetration and less interference compared to 2.4 gigahertz protocols. Z-Wave uses a mesh technology, network topology as well, allowing devices to act as repeaters and extend the network range. While Z-Wave offers good capability between devices from different manufacturers, its proprietary nature and limited bandwidth can present integration challenges when incorporating it into larger IoT ecosystems. A third protocol is Wi-Fi, which is based on the IEEE 802.11 standard. It is ubiquitous protocol in smart homes due to its widespread availability and high bandwidth. It operates in the 2.4 gigahertz and 5 gigahertz frequency bands, and is suitable for data-intensive applications like video streaming and file sharing or file transfers. However, Wi-Fi's higher power consumption and potential network congestion is densely populated. In densely populated areas can pose challenges for battery-operated devices and overall systems reliability. Our next protocol is Bluetooth Low Energy, or BLE as is known. It is also known as Bluetooth Smart. It is a powerful, efficient version of the classic Bluetooth protocol. It operates in the 2.4 gigahertz band, and it is designed for short-range communication with minimal energy consumption. BLE is commonly used in wearables, sensors, and smart home devices that require frequency data transmissions but have limited battery capacity. Integration challenges with BLE can arise from its limited range and potential interference in crowded 2.4 gigahertz environments. Our fifth protocol is an IPv6 based protocol, Thread, as it is known. It is low power mesh networking protocols designed for IoT devices. It operates on the same IEEE 802.15.4 radio technology as Zigbee, but offers native IP connectivity, making it easier to integrate with existing IP-based networks. Its self-healing mesh capabilities and support for sleepy end devices make it suitable for various smart home applications. However, its relatively recent introduction and limited market adoption can present challenges when integrating with existing smart home ecosystems. And our last protocol is Matter, formerly known as Project CHIP, CHIP, Connected Home over IP, which is a new open source smart home standard developed by the Connectivity Standards Alliance and aims to unify different smart home ecosystems by providing a common language for devices to communicate, regardless of their manufacturer or underlying communication protocol. Matter supports Wi-Fi, Thread, and Ethernet as transport layers and uses Bluetooth Low Energy for device commissioning. While Matter promises to solve many interoperability issues, its recent introduction means that integration challenges may arise during the transition period as manufacturers adopt the new standard. Now, what is being done? What are some approaches to these challenges? Well, the first one is standardization efforts. One of the primary approaches of addressing interoperability challenges is through these efforts, standardization efforts. Industry-wide standards aim to create a common language for devices from different manufacturers to communicate seamlessly. Matter protocol, for example, this standard, developed by the Connectivity Standards Alliance, as I said before, is a significant step towards solving interoperability issues. It provides a unified communication protocol for smart home devices, regardless of their manufacturers or underlying technology. It is supported by major tech companies like Amazon, Apple, Google, which increases its potential for widespread adoption. That is a good point for Matter. Open Connectivity Foundation, the OCF, which provides a common framework for IoT devices to communicate with each other. It supports interoperability between different protocols and standards, making it suitable for large-scale IoT deployments. Another approach is interoperability platforms and gateways, which act as translators between different protocols and standards, allowing devices that use different communication methods to work together. Cloud-based platforms, services like AWS IoT Greengrass and Microsoft Azure IoT Hub serve as intermediaries, facilitating communication between devices using different protocols. These platforms can translate between various standards, enabling seamless integration of diverse smart home devices. Smart home hubs. It's another example, which these are devices like Samsung Smart Things or Apple HomeKit, which serve as central control points, allowing users to manage multiple smart home devices from different manufacturers through a single interface. A third approach found in our literature review is open source initiatives. So these open source projects contribute to interoperability by providing freely available software and protocols that can be implemented by any manufacturer. Home Assistant is one of those. This open source home automation platform supports a wide range of devices and protocols, allowing users to integrate various smart home products into a single system. OpenHAB, OpenHAB, as you can see in the slide, is another open source platform that integrates different home automation systems and technologies into a single solution, enhancing interoperability. A fourth approach is multi-protocol devices. Manufacturers are increasingly developing devices that support multiple communication protocols, enhancing their compatibility with various smart home ecosystems like Silicon Labs multi-protocol, system and chips, support multiple protocols like Thread, Wi-Fi, and Bluetooth LE, allowing devices to communicate across different smart standards. A fifth protocol is artificial intelligence and machine learning, very promising area. These AI and ML technologies are being employed to promote devices interoperability by enabling smart systems to learn and adapt to different protocols and user behaviors. Predictive maintenance, like AI algorithms, can analyze data from various smart home devices to predict potential issues and optimize systems performance, regardless of their devices manufacturers. One last approach is industry collaborations. Collaborations between companies are fostering interoperability by creating ecosystems where devices from different manufacturers work together seamlessly. Works with Alexa, Google Home. These programs ensure the third-party devices are compatible with popular voice assistants, enhancing overall smart home interoperability. While these solutions and approaches are making significant strides in addressing interoperability challenges, the smart home IoT landscape continues to evolve. The success of these efforts will largely depend on widespread adoption by manufacturers and consumers, as well as ongoing collaboration within the industry to refine and improve interoperability standards and technologies. The analysis of current solutions and approaches reveals significant progress in addressing interoperability challenges in smart home IoT protocols. Standardization efforts, particularly the Matter protocol, show promise in creating a unified communication standard. Interoperability platforms and gateways offer practical solutions for integrating diverse devices, while open source initiatives provide flexible options for users and developers. The development of multi-protocol devices and the application of AI and ML technologies demonstrate the industry's commitment to enhancing compatibility. However, the success of these efforts largely depends on widespread adoption of manufacturers and consumers, as well as a continued collaboration within the industry. While these solutions are making strides in improving interoperability, challenges remain. The smart home IoT landscape continues to evolve. The ongoing research and development are necessary to refine and improve interoperability standards and technologies. Future work should focus on evaluating the real world performance of these solutions and their impact on user satisfaction in smart home environments. With this, we conclude, and thank you so much for your attention. We appreciate any questions you may have. We'll be happy to answer them.